Alright, geometry students, so today we are in our final lesson of topic 2. We are going to talk about the equations of parallel and perpendicular lines. So we should be able to write equations of lines parallel and perpendicular to other lines using points and slope. So in today's lesson we will cover point-slope form. I know we're familiar with slope-intercept form very well. We are going to use point-slope form to find lines parallel to each other and lines perpendicular to each other, and also apply our knowledge to talk about perpendicular bisectors on a coordinate plane. So make sure that you are following along in your guided notes, and let's get started. So first thing we want to talk about is point-slope form. I know that we are used to slope-intercept form, which looks like this: y equals m times x plus b. And now x and y are our xy coordinates. M is our slope, and b is the y-intercept. So this is what we're used to. And this format is very useful for determining, of course, y-intercept. That's why we like this format. There's also standard form, which is used less often, and it's for determining the x and y-intercepts on a line. But let's talk about point-slope form today. This is really useful when you are given the point, one point on a line, and the slope of the line. So when we're given a point, x1, y1, through which the line passes, and the slope of the line, we can write the equation in point-slope form, and it looks like this: y minus y1, or our given y-coordinate, is equal to m, our slope, times x minus the x-coordinate. Y minus y1 is equal to m times x minus x1. And in order to convert this equation to slope-intercept form, like what we're used to, we would distribute and solve for y. So here's an example. Let's say I'm given a slope of 3 and a point that is 6, 2. Well, I can write it in point-slope form like this. I know 6 is x1, that's my x value, and 2 is y1. So it would go like this: y minus 2, y minus y1, is equal to m, 3, times x minus x1, which is 6. And we would distribute and solve for y to put that in slope-intercept form. Let's try some examples. We're going to write these, using these values, we're going to write linear equations in slope-intercept form. But we need to stop at point-slope form along the way. Okay, so we're given in problem 1 the coordinate 4, 1, and a slope of 2. So if we write this in point-slope form, that's why this form is really handy for us, because we don't need 2 points, we can write it like this: y minus y1, which is 1 here, is equal to m, 2, times x minus x1, which is 4. And so what we need to do to write this in slope-intercept form is solve for y. So we need to distribute on the right side of the equation. Distribute the 2, and we get y minus 1 is equal to 2x minus 8. 2 times negative 4 is negative 8. And we need to move this negative 1 to the other side of the equation. So our equation in slope-intercept form would be y equals 2x minus 7. So the line that passes through the point 4, 1 with a slope of 2 has the equation y equals 2x minus 7. Let's try one where we're just given 2 points. Well, in this case, we're not given a slope, and so we're going to need to use these points to find slope. So to find the slope, we are going to subtract our y values from each other, 7 and negative 1, in the numerator, 7 minus negative 1, divided by our x values subtracted from each other, negative 3 minus 1. 7 minus negative 1 is the same as 7 plus 1, that's 8. And negative 3 minus 1 is negative 4, so our slope is going to be negative 2. So now to write this equation in point-slope form, we don't have to find the y-intercept at all. We're just going to write this in point-slope form and then convert to slope-intercept. I'm going to use the coordinate negative 3, 7, and the slope of negative 2. So my y value is positive 7, so it's going to be y minus 7, y minus y1, is equal to slope, which is negative 2, times x minus x1. Now notice this is a negative 3. This would be saying x minus negative 3. So we're just going to write it as x plus 3. X minus negative 3. Double negative here. Okay, now we'll distribute like normal. Negative 2 multiplied by x and by positive 3. So y minus 7 equals negative 2x minus 6. And then adding 7 to both sides of the equation. So our equation in slope-intercept form would be y equals negative 2x plus 1. So we had to add on an extra step here. If we're not given slope, we need to use the two coordinates we have to find slope first. And if you would like additional practice, problems 2 through 4 cover how to find the equation in slope-intercept form just given a point and slope. 6 through 8 cover how to find the equation given just 2 points. Now let's get into our talk about parallel and perpendicular lines, and let's start with parallel lines. We know from our last lesson that parallel lines have the same slope. That's how they never intersect. They have the same slope. So we want to be able to write the equation of the line that is parallel to 6x plus 5y equals negative 10 and passes through the point negative 10, 9. The first thing I want to do is, well, first of all, I don't really know the slope of this line by just looking at it. So I'm going to solve this equation for y in order to find the slope. That way I can continue with my problem. So let's rewrite this equation over here. 6x plus 5y equals negative 10. I'm going to solve for y, get y by itself. So I'm going to subtract 6x from both sides. And I'm left with 5y is equal to negative 6x minus 10. And now to get y by itself, I'm going to divide everything by 5. That includes dividing 5y by 5 and this entire expression on the right side of my equation by 5. So I get y is equal to, well, negative 6 divided by 5 is just the fraction negative 6 over 5. And then negative 10 divided by 5 is negative 2. So the equivalent equation to this one is y equals negative 6/5 x minus 2. And we want to write an equation that's parallel to this line, which means our slope of the new line is going to be negative 6/5. And we're going to use the point negative 10, 9. So let's write our new equation in point-slope form. Y minus y1, which is positive 9, is equal to the slope, which is negative 6/5, times x minus negative 10, which is just x plus 10. And so now we need to put this equation in slope-intercept form. So I'm going to distribute. So I get y minus 9 is equal to negative 6 over 5x, and then negative 6/5 times 10. If I just write this off to the side here and I multiply, well, I know this is going to reduce. Okay, and then I get, it's going to be negative 6 times 2 is 12. And then to finish solving this equation for y, I'm going to add 9 to both sides of the equation, and I get y is equal to negative 6 over 5x. Negative 12 plus 9 is negative 3. So the equation is y equals negative 6/5 x minus 3. For additional practice with finding lines parallel to given lines that go through a certain point, try out problems 9 and 10. Now let's talk about perpendicular lines. For perpendicular lines, remember, perpendicular lines have opposite reciprocal slopes. Opposite reciprocal. And remember that opposite reciprocal just means taking a fraction, let's say 1/3, positive 1/3, we're going to change the sign of the number, so from positive to negative, and we're going to flip the fraction. So 1/3 becomes 3 over 1. The opposite reciprocal of 1/3 is negative 3. So, looking back at this problem, we're going to write the equation of the line that is perpendicular to x plus y equals negative 5 and passes through the point 7, 3. So just like last time, I have an equation that is not quite set up for me to know the slope yet. So I'm going to take this equation in standard form and convert it to slope-intercept form by solving for y. So this one's a pretty easy one. I just need to move the 1x. I'm going to subtract 1x from both sides of the equation. And I get y is equal to negative 1x minus 5. The slope of this line is negative 1. Remember, when there's no 1 written, it's implied. There is a 1 here. So the slope is negative 1. Well, the opposite reciprocal of negative 1 would be this. We change the sign, it's going to be a positive number, and then we flip the fraction. So the slope of the line perpendicular to this one is going to be positive 1. So let's rewrite this equation in point slope form. New line slope is going to be positive 1, and it passes through the point 7, 3. Writing the equation in point slope form, y minus y1, which is 3, is equal to 1, the slope, times x minus x1, which is 7. And we distribute 1 into the parentheses. Y minus 3 equals x minus 7. And we're going to add 3 to both sides. So our equation of the line perpendicular to x plus y equals negative 5 is y equals x minus 4. For additional practice on this concept, try out problems 12 and 14. And I've got one more concept here. We're going to talk about perpendicular bisectors. So if you think back to our lesson on perpendicular bisectors, remember it's when a line or a segment is cut in half at a 90-degree angle. So let's say you've got a segment here, and these two portions are now the same length, and the bisector right here forms a 90-degree angle with the segment or the line. Okay, so segment AB is formed by points A, that's a negative 1, 4, and I'm going to go ahead and graph these right now. A is at negative 1, positive 4. And B is at 5, negative 2. 1, 2, 3, 4, 5, negative 2. So we've got segment AB. And we're saying if line L is the perpendicular bisector of segment AB, we're going to write a linear equation for line L in slope-intercept form. And we want to graph both the segment and the perpendicular bisector to confirm our answer. So I've already done the work here. I've graphed segment AB and the points, and now I need to figure out this line. Well, I know a perpendicular bisector forms a right angle with my segment, and it cuts my segment in half. So we're going to need to do two things. First, we need to find the slope of line L, and then we need to find the midpoint of segment AB. So we're finding the slope and midpoint of this segment. Let's find slope first. Slope of segment AB. Well, we're given the points of AB. We're going to put them in slope formula. 4 minus negative 2, or 4 plus 2, divided by negative 1 minus 5. So 4 plus 2 is 6. Negative 1 minus 5 is negative 6. So the slope of AB is negative 1, has a rise of negative 1, a run of positive 1. Now we need to find the midpoint because we want line L to bisect segment AB. And we know that to find the midpoint of a segment, we take the x values and add them together, divide them by 2. Negative 1 plus 5 divided by 2. You're technically finding the average of the 2 points. And then do the same thing for your y coordinate. 4 plus negative 2, or 4 minus 2, divided by 2. And when I do the math, negative 1 plus 5 is positive 4. Positive 4 divided by 2 is positive 2. And 4 minus 2 is 2. 2 divided by 2 is 1. So the midpoint of segment AB is at 2, 1. I did a pretty good job of finding the midpoint there. So there's my midpoint. I know that line L is going to pass through this point. So now I need to find the slope of line L. So line L, the slope needs to be the opposite reciprocal to the slope of AB. So the opposite reciprocal of negative 1 would just be positive 1. And then I get to choose which point I would like to use to put in point slope form. That's the midpoint. I need my line to pass through the midpoint, which is at 2, 1. So let's put this in point slope form. Y minus y1, which is positive 1, is equal to my slope of 1 times x minus x1, which is positive 2. And I distribute the positive 1. And then I'm going to add 1 to both sides of the equation to solve for y. Line L should have an equation of y equals x minus 1. And let's prove that with a graph. So the y-intercept of line L is negative 1. We start here. And my slope is positive 1. So rise of 1, run of 1. Rise of 1, run of 1. There we go. It passes through that midpoint. And we keep going, and I'm going to draw as good of a line as possible. There we go. So the red line is line L. And you'll notice that it cuts segment AB in half, and it forms a right angle with segment AB. Pretty cool. To practice this specific skill, try out problem 16. And that is our video, ladies and gentlemen. Make sure that you are trying out additional practice problems for these skills. Check your answers with my filled-in notes in our Topic 2 Notes tab in the Content Library, and ask me for support if you need it. Thank you again for watching. Have a great day.